Good morning, everybody. Today we're going to talk about inscribed angles and intercepted arcs and things of that nature. Now, I've only got about 15 minutes to get this lesson done, so I'm going to try and get through as quick as possible. You will be able to pause and do anything that you need to do in order to go back. Now, I'm going to write on this with my writing, and it's going to be my voice going over it, so do the best you can. If you have questions, make sure you ask me. Generally, I am on a Google Meet every day from 10 to 11 for geometry. So here's what we're going to have. An inscribed angle is an angle with its vertex on the circle. Let's try to turn on a light here. Maybe that'll be better for us. Yeah, that's better. On the circle with two sides that are chords. Now, over the last couple days, you guys have been watching some videos on what these things are. A vertex is the corner of the angle. A chord has its endpoint as a segment whose endpoints are on a circle. So like AB is a chord and CB is a chord. Angle B is the vertex. So that is the vertex of the inscribed angle. An intercepted arc is the arc that lies between the endpoints of the inscribed angle. Okay, the endpoints of an inscribed angle. So what they're talking about is the intercepted arc of angle ABC is arc AC. Now, if you remember in previous lessons that you've talked about major arcs, minor arcs, and semicircles. Remember that major arcs are anything greater than 180 and less than 360 degrees. A semicircle is equal to 180 degrees, and a minor arc is less than 180 but greater than 0. And remember that minor arcs are labeled with 2 letters. Major arcs and semicircles are labeled with 3 letters. So a minor arc here would be arc AC. A major arc here, bigger than 180, would be arc ABC. Now, the measure of the inscribed angle is equal to half the measure of its intercepted arc. So that means the measure of arc ABC, or angle ABC, would be half the measure of arc AC. And that does make sense because if you remember right, the biggest angle that you could really have is 180 degrees, and there are 360 degrees in a circle, so that's kind of where that half comes from. Now, if an inscribed angle intercepts a diameter, remember a diameter is half the circle, then it is a right angle. Okay, it is a right angle. Half of a circle is 180 degrees, so half of 180 would be 90. So that means angle A would be 90 degrees. The measure of angle BAC is what I just said there, is 90 degrees. Now, when we have overlapping arcs, if two inscribed angles intercept the same arc, then the angles are congruent. Okay, the measure of angle ABD, which is this angle right here, would be the same as measure of angle ACD. Okay, another way you can say that is angle ABD is congruent to angle ACD. Okay, so that's a little bit of our vocabulary today. Now, I'm going to put an empty version of this on your Google Classroom page. I'm also going to put this version of that on the Google Classroom page. Okay. Now we're going to go over some examples here. Hopefully we'll be okay. In the first 6 here, I'm going to go over a couple of these. The first 6 here says find each angle and or arc measure. Now if we look at number 1, we're looking for the measure of angle WXY, which is this angle right here. It intercepts this arc here, so that means the inscribed angle is half the intercepted arc, so that's going to be 1/2 of 62 or 31 degrees. Okay, this angle is half of this intercepted arc. Okay, so if 113 degrees times 2 would be 226 degrees. Okay. Again, if you're going from the arc to the angle, you divide by 2. If you're going from the angle to the arc, you multiply by 2. Now, in number 3 here, it says the measure of angle PQR is what we're looking for. So the measure angle PQR, PR is a diameter. So that means the measure angle PQR is going to be 90 degrees. Okay? Pretty much the same thing for 4, 5, and 6. I'm going to leave those to you guys if you want extra practice. If you want extra practice on that, you can ask me to see if you are correct. Okay? Now, if we take a look at number 7, number 7 says, let's find the value of x. I'm going to turn off this light to see. Maybe that's a little bit better for you guys. We'll see. Okay, we're finding the value of x. Now, we know the angle is half the intercepted arc. So 8x minus 9 is going to be 1/2 of 158. Okay, half of 158, if we go to our calculator, half of 158 is going to be 79 degrees. So if I take 79 plus 9, I get 88. Divide that by 8, x will be 11. That's where our math comes in. Okay. Now in number 8, we know the angle is half the intercepted arc. So the angle is half the intercepted arc. Okay, I'm going to multiply both sides by 2. 67 times 2 is going to be 134. Is equal to 4x plus 58. Okay, again, I multiplied both sides by 2. And that's where that came from. Okay, I'm going to subtract 58 from both sides. So 134 minus 58. Oops. Try it again. Be 76. Divide 76 divided by 4 will be 19. X will be 19. Now again, you just have to remember the intercepted arc is twice the inscribed angle, and the inscribed angle is half the intercepted arc. Okay? I'll flip it over to the other side. Okay? Now, if we take a look at number 9, okay, they're going to be a little bit more difficult here. Okay? Now, number 9 says, well, what's the value of x? Well, since this is a diameter, I know this is going to be 90 degrees. So 13x minus 1 will equal 90. 13x will equal 91 because, again, we're going to take the 1 or move it to the other side. 91 divided by 13 is going to be 7. Okay, let's take a look at number 11. Okay, now if you remember right, in number 11, we know there's 360 degrees in a circle. So if I take 360, subtract 162, subtract 92, I know this arc here will be 106 degrees. Again, 360 degrees in a circle. Subtract the 2 arcs out there, we get 106. So I know then that this angle 7x minus 10 is 1/2 the arc. Okay, so if I take 106 and divide it by 2, I get 53. Let's try it again. I'm going to add 10 to both sides. Oops, this should be 53, not 56. So 7x will equal 63, and I hope we know our math by now. X will be 9. Okay. Ooh, number 12 looks like a fun one. Got about 5 minutes left, so we're good to go. If I take a look at number 12, I'm looking for x right here, which means it's right there. Now, it's really not going to help you too much, but I know that if the inscribed angle is 67, if I take 67 times 2, I'll get 134. And I know there's 360 degrees in a circle, so if I take 360 minus 120 minus 134, I get 106. So that means 5x plus 21 will equal 106. I'm going to move the 21 to the other side. I'll get 85. Divide that by 5. I get 17. X be 17. Again, that's pretty much the idea. Now, if we take a look at number 13, I'll only do 13 and maybe another one. Let's see if we have time. Angle FGH is 6x plus 21. Arc FJH, which is this arc out here, be 17x minus 28. So I know the angle is half the intercepted arc. The way I would do that, since I don't like fractions, I'm going to multiply everything by 2. So this will cancel with this. 12x plus 42 equals 17x minus 28. There are more x's on the right side of the 17, so I'm going to bring this over here. I'm going to bring this over here. 42 plus 28 is 70. 17x minus 12x is 5x. 70 divided by 5 is going to be 14. But remember, we have to find the measure of arc FJH. Well, FJH is 17x minus 28. And again, it's 3 letters, so that's going to be bigger than 180. So if I take 17 times 14 and subtract 28, I get my answer. The measure of arc FJH is going to be 210 degrees. So make sure when you're doing these problems you answer all the questions that you need. Okay? I'm going to stop there. If you have any questions, remember I'm going to be online between 10 and 11 today.